So here we're creating a graph for a scenario, a displacement time graph. Very powerful tool because we need to be able to represent real world scenarios using graphs and models. We've got Finbar, the fantastic physicist, the solver of unsolvable problems. He is running at a running club, an unnamed running club, and he runs the first 300 metres in 60 seconds. Okay. He stops for 30 seconds, he then runs back to his origin and takes 90 seconds to do so. So he takes 90 seconds to return from his origin after his 30-second rest. What we need to do first of all is set up our displacement time graph. So which of these variables do we think is the independent variable? Which one does not get changed with the other? Time. So time goes on the x or the y? X-axis. So we put time down here. That means what is our y or our dependent? Displacement. Now, am I good just doing that, or do I need to add something else? The units and the numerals. So the units for time are? And meters is the unit for displacement. So what do we think would be an appropriate amount to go up by for our time? What time do I need to get to?
180.
180. Okay, I've got 1, 2, 3, 4, 5, 6 intervals. What should I go up in? 30s. So on the bottom 30, 60, 90, 120, 150, 180. And I've got 1, 2, 3, 4, 5, 6. What amount of displacement do I need to maximum get to? What's his displacement maximum? 8? Oh, good point. Actually, we'll do that. Why not? So what's a good amount to go by?
50.
We've got 6 intervals. If we were just doing this graph here, the one that we've looked at with him reaching 300, 50 would be appropriate. But because we know we're going to be using the graph over there, 100. So let's go up in hundreds. 100, 200, 300, 400, 500, 600. And again, we don't need to go 600 metres in this one, which we'll discover in a second. So, in his first 60 seconds, he travels 300 metres. What do we think I should do? Put a dot where? So I should go up 300 on the y, go across to 60 on the x and put a dot there. Just going to put a little x. Happy with that? Then what should I do?
He stops for 30 seconds.
Stops for 30 seconds. So how far does he travel?
0.
So where should the next x go?
90, like right next to it.
90, but for the y?
Yeah.
300 up. Okay, and then where's my next x going? So he travels 300 metres again, correct?
Yeah.
So is it 600? Ah, why would it be down? Yeah, so back down at the 0 there. There's another x I'm missing, you need to put that on there. Good morning, Doug speaking. Yep. No problem, we'll do. Right, wait. Where's my last x that I'm missing? I know something else about this graph. Yep, 0, 0.
Attention staff and students, sorry for the interruption. Any Year 10 student that has not had a jacket fitting, please make your way to DO5 when the bell rings. Thank you.
What now? What should I do now? Yep, so draw lines to meet the dots. I haven't got a ruler because I've removed them from the room. So that's one line look a bit wonky. Now, that's a displacement time graph. 4 minutes. For question B, I'm going to label these sections. So between 0 and 60, I'm going to label this A, I'm going to label this B, and I'm going to label this C. can we please find our velocity at A, B and C? Now remember the equation for velocity is what? Displacement over time. So you might need to think about where he starts and where he finishes and how long it takes him to get there. Then once you've completed that, can you please graph Andrew is going, or maybe not Andrew because Andrew didn't get it. We'll go Alex. Alex, the awesome, is going for a run and he has run his run like so. So can we please, different representation of the same type of problem, okay? Rather than it being a word problem, I've given you coordinates. So we can plot that on the same graph is fine. Okay, good luck.